Hey everybody and welcome to the Math Jedi. It's a massive review time. That is right, we're looking at rationals. This is going to give you the top tips and tricks that evil math teachers sometimes use. Are you ready? Here we go. Okay, so welcome to a massive review of rationals. If you have seen any of my videos, you will have an idea about what's going on, but I want to highlight some things I like to call the common kid mistakes. I also want to highlight things that math teachers are always kind of testing and making sure that you are aware of all the little tricks and tactics that math teachers do on tests, because that would be very helpful, especially if you happen to be a student of mine or anyone who might be writing a test upcoming soon. So let's just start really quickly. We're going to focus a little bit on, let's get a different color, adding and subtracting. So we're going to focus on adding and subtracting first off. And I want to just remind, so some reminders. So here we go. So reminder number one. Always ask yourself, is your answer going to be positive or negative? So that's the first thing you want to look at. So when you're looking at the numbers, and I'll give you an example right now, is let's say we had an example that was, I don't know, negative 12.7, takeaway, negative 8.2. Let's say you had something like that, and you're looking at this and you're going like, well, first off, I'm hoping you're going to notice that you have, look at some different colors there. Let's say, I hope that you notice that you're having a double negative, so that's going to become a positive. So you guys, first off, you're noticing that. So you have a negative 12.7 plus 8.2. So when you're asking yourself, is it going to be positive or negative, you have more negatives or positives. So this one you have more negatives. So right away you know that. Also, number two is if you have different signs, what do you always do? Different signs means that you are going to subtract. And that is one of the things. So you look at this, you say you have a negative number and a positive number. You have a negative number there and you got a positive number there. So we're going to be subtracting. So you should be thinking, oh, okay, I'm going to be subtracting. So subtract, subtract, subtract. So let's go and do that. Well, you put your big number on top, you line your decimals up, and you just go and subtract. Now, a couple of things. Notice how I haven't even put that negative number there, that negative sign there, did I? I didn't, because it doesn't matter, because I know my answer is going to be negative no matter what. I know that already, so that's pretty cool. So make sure that our decimals are lined up. Always, always, always. So these are lined up. And then start subtracting. So 5, you have a decimal point there. Got to do a little bit of borrowing. And you get this. There you go. So your answer is negative 4.5. Awesome. So there's that negative right there. Because you follow that order. Different signs means you always subtract. Really, really important. And I'll do one more example, because obviously if different signs means that you always subtract, then you need to also know that number 3, same signs means add. And there's a trick. Take the sign. So if you have, and we'll just stick with negatives because why not? So example, let's say you had negative, I don't know, 14.2, take away, I don't know, 6.3. So you're saying, well, I have two negative signs, and that means they're the same. So I'm going to add them together, but I'm going to take that sign. What do I mean by that? I mean we're going to be taking the sign. So they're both negative, so my answer is going to be negative. And because of that, we always go and add. I'm going to line up my decimals. I'm going to line them up, and I'm going to add. I'm going to add. So stuff like this, and There's my little decimal point. I'm going to add and do a little bit of carrying there, and I get 20.5. And remember, I'm going to take that sign, so my answer is negative 20.5. So far, so good? So that was adding and subtracting rationals, so some decimal numbers. Of course, the other flip side is going to be fractions. Are you ready? So how does adding and subtracting fractions work? What's the big top tip? Well, I'm glad you asked, because this video is all about top tips. So here we go. Fractions, top tip. And this kind of goes against maybe some of my older videos of what I always say. You don't always have to convert to an improper. So don't always convert to improper. So I'm going to give you one example that always catches students to see where you're working the most efficient. I'm definitely a fan of using improper fractions, but I'm also the bigger fan of efficiency. So here's my example. Let's say you had something like this. 12 and 2/3, and you're going to go and subtract, I don't know, 18 and 1/4, and you'll also subtract maybe a negative number, 16 and what's another good one, 5/6. Ooh, that's a doozy. That's a doozy right there. Now some students might say, I'm going to go and convert all of these to improper. I'm going to go and do that, and I'm going to make this be 38/3, take away, ooh, what's that, 73/4, I think. And remember double negatives, I'm going to add this one, and oh gosh, what's that, 96, 101/6. Ugh, now I need a common denominator of 12, and now, okay, what's happening? It's getting crazy. But you would get the answer. Let's talk about efficiency though. Let's not do that. Let's just kind of cut that up. So when I say don't always convert to improper, you could just deal with the fraction part separately. What do I mean by that? I want to deal with this stuff. 2/3. I want to take away 1/4, and I want to add 5/6. So notice what I've done. I've used this, 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 and I've taken the signs. And this is a positive, don't forget. I'm doing that because now this becomes basically a much easier question. Common denominators of 12, cool. And this will become 8, this becomes, I think, 3, and this will become 10. Now if I do all that, what does that become? Oh, I love this question. This becomes 15/12. Sweet. Now I'm going to go and deal with the whole numbers. So if I dealt with the whole numbers, I'm going to go over here just for some space. Okay, a little bit kind of awkward, but here we go. So 12 minus 18, I'm going to add 16. So I'm going to go and do that. And here I think I get, what do I get? I think I get 10. So I put it all together, and there's my answer, right? Let's get another little area here. Where's another area? What other color could I use? Ooh, how about some purples? The purples looks pretty cool. So, whoa, oops. Like that. There we go. Okay, so my answer, my final answer is, of course, going to be 10. Where it is? 10 and 15/12. Uh-oh. Now, this is a great thing. This is what teachers do, math teachers do. Because you can't do that. You need to simplify this, 10 and 15/12. Remember, 15/12 is really a whole and 3/12. So 1 whole and 3/12. And I'm even going to simplify that more over here. And that's 1 and 1/4. So I need to add, so I'm going to convert this. This 15/12 is 1 and 1/4. So that's really saying this, 10 plus 1 and 1/4. And that will give me my final answer of 11 and 1/4. Notice the numbers I've been dealing with are fairly small, fairly manageable. It's not crazy. So there's another top tip when dealing with rational fractions and subtracting and adding. Let's stay on fractions. Why not? Let's stay on fractions. And some more little reminders. When multiplying or dividing, make sure you are cross-reducing first. Again, I'm trying to give you tips that are going to make your life easier. So cross-reduce. So here we go. Here's some examples. Actually, I'll probably just give you one. Let's give you a monster example. Let's say you had 12 over 20 times 18 over 10, and you divided it by, I don't know, 3/4. That sounds exciting. So a couple things. First off, keep, change, flip. So it really matters about this part here. We're going to change this. So keep the 18 over 10. We're going to change this to multiplying, and we're going to flip this. So our new question becomes 12 over 20 times 18 over 10. I'm going to multiply it by now 4 thirds. Sweet. Now let's go back to maybe some happy green colors. I want to cross-reduce. Now one thing I want to show you, there's so many different ways you could reduce. You could reduce each fraction individually. Those two you could go and reduce. But I want to show you one way to cross-reduce that a lot of students don't look for. A lot of students just look for this, 12 and 10. That can be reduced. But what I want to show you right now is you can actually reduce 12 and 3, as long as this is on a cross. So watch what I'm going to do. I'm going to divide this by 3, make it 1. Divide this by 3 and make it 4. You can do that. I'm also going to go and reduce here by 2. I'm going to divide it by 2. And divide this by, actually, you know what? No, stop. Wait. Hope you didn't write that down. I'll do another giant cross. Look at this. Divide 4 into itself, leaves it with 1, and this becomes 5. That was so cool. And let's keep reducing. So organization is really important. Let's keep reducing. Let's break out some orange. I'll have a 4 and the 10. I'm going to make this become 2, and this become 5. Like that. Is there anything else that we can do? No, but look what we've just created now. This says this now. 2/5 times, oops, there you go, 18/5 times 1. This isn't too bad. Multiply across the top, 36, across the bottom, 25. You know I love leaving things in improper fractions as long as they're simplified, and there you go. So that's looking at some rationals with some decimals and some fraction action. Hopefully that has been very helpful. Let's take a look at replacement, shall we? So, again, big hints. So this is replacement. I like to call it replacement. A lot of teachers will call this evaluating an expression. That sounds really fancy, doesn't it? So this just means when you're told a letter is equal to something. So let's take some really fancy letters. And let's use W is, I always like going nice and simple. So W, X, let's get some negatives. Why not? And of course, a fraction. A quarter is always a friendly fraction to use. And let's just see when you start to get all crazy. So here we go. Let's say you had WX and you times that by a X, take away Y. This is becoming monster, right? Should we go plus a quarter? So sure, plus Z. Let's see what happens. And let's divide all that. What? Negative X, take away W. Lots of stuff going on. I love using brackets, and I think this is how I would set it up. My ideal situation. So I'm just going to set this up right now. And you'll see, I'm trying to just gonna set things up nice and what I would consider pretty. And basically, I do this. It takes an extra probably 20 seconds, but you know what? I don't make mistakes. And now this is the kind of the interesting part. I'm going to use some square brackets because you have brackets and brackets, don't you? So this will hopefully stop any kind of issue. So you can kind of see what I'm doing there. I'm going to put in some numbers now. Use a nice little red color. So W was 2. X was 3. Don't forget, when two letters are kind of beside each other, that means you're multiplying. That doesn't mean the number is 23. Don't do it. Don't do it. That just makes me get angry. This is a double negative happening right here. So it's a double negative, so be careful. Careful. And of course we have a quarter. I don't know why I put that there, but I just did. Over here, again, this isn't too bad. This is a negative negative. So this is what you have. So look how nice and pretty that looks. Worst case scenario, you get this question wrong, your teacher's going to give you half a mark because you've shown all your work. You're showing that you understand how to set it up. And that's kind of the mindset that a lot of teachers will be looking at. It's like, okay, you showed your work, you tried really hard, I get it. So let's just go and see what happens here, right? On the top, we get 2 times 3, which is 6. 6 times, what's that? Ends up being 5 plus a quarter. Divided by this negative 3 minus 2. That's always a good one. It's going to be negative 5. Like that. So let's go and follow our order of operations. And we get 30 plus a quarter divided by negative 5. So this is 30 and a quarter. Right? 30 and a quarter. Does that make sense, right? 30 and a quarter. So if I really was going to make that into a improper, I would say that's 121 over 4. A fraction means we're dividing by negative 5. And keep change flip, which is really, I'm running out of room. 121 over 4 times negative 1/5. Which, let's change colors to make things all nice and happy. That would just give us a negative 121 over 20, and I know I can't reduce that one. And there's my final answer. Couple things. Don't get intimidated by this. You can do it. You just work slowly. Ask yourself, can you multiply 2 numbers together? Yes. Can you add something? Yes. Can you go and divide something? Yes. So yes, you can do those questions. It just takes time and a little bit of effort, and you will be there. Guaranteed. Promise. Converting fractions. So one of the things that typically shows up in rational units is converting fractions. So again, some top tips. Number 1, look at place value. Really important that you know your place values. And the other one is when you're simplifying, look to divide by 2 or 3. A lot of times students will be looking at a question, they don't know what to do. So if you have some strategies of what to do, then that really is helpful. So look to divide by 2 or 3. Here's some examples. We're going to convert things to a fraction for this one. Let's say you had, I don't know, 0.76. We're looking at place value. Tenths, hundredths. This is the hundredths. This is hundredths. So we get 76 over 100. This is an even number, so we can be dividing by 2. So I think that, what does that give us? 35 and 3, so 38. Is that 38, I think? 38 over 50. And then you keep dividing by 2. So that will give us 19 over 25. You probably could have divided this by a bigger number. However, that would require some more cognitive capacity on your part. Why not just divide it by 2 twice? That seemed a lot easier and a lot less stressful. Don't forget, when you have, let's say, a repeating Students love repeating. Let's see. Let's say you had negative 7.16. And should we start with, yeah, sure. Let's start with both things, both digits repeating. Remember, for every repeating digit, you are getting a 9 in the denominator, so there's 2 digits repeating, so you do that. And you put the original decimal on top. Don't forget, so many students forget the negative 7 part, and like that. Now ask yourself, most students say like, wait, can you reduce this? Could you divide this by 3 or 9 or 11? Those are the easy ones to look at, right? Well, how do you know that? You know the trick for 3s? You know what the trick is? Here's the trick. You add the digits up, add them up, 1 plus 6. That gives you 7. Is 7 divisible by 3? No. That means this is not divisible by 3. Cool. So your final answer was negative 7 and 16/99. Sweet. Next one. Let's continue on the same topic. Partially repeating digits. So let's do the exact same question, but this time I'm going to say it's 0.16. Only the 6 repeats. So this one's a little bit different. Repeating digits get a 9. This one gets a 0. Non-repeating gets a 0. So many students love to do this. Oh, okay. So the Math Jedi said it was 0 for that, so I'm going to put it over 0.9. When you count, when you learn to count when you're like 2 years old, did you count 0.1, 0.2, 0.3, 0.4? Does that seem weird? Does this seem weird? Does it seem a little bit like, what? Yes, it does seem weird. It goes the other way. It's 90, not 0.9. So you should have had negative 7 and 16 over 90. But wait, don't forget the last part. Because this is partially repeating, you need to subtract the non-repeating part. So I need to subtract that 1. So I get negative 7 and 15 over 90. Double weight. You can simplify this. Divide that by 3. So, actually, can you even divide by more? Could you? I don't know. Let's see. So see, I didn't even think about it. Could I divide by a bigger number? So I'm divided by 3 because I know that's nice and easy. And oh my gosh, you could. So my final answer is negative 7. Divide that by 5, and you get negative 7 and 1/6. Boom. There you go. Some converting things. Last one. Let's get rid of that. How do I do this? Get rid of that. Boom. There it goes. See ya. Don't forget, when you're converting fraction to decimals, make sure the right things goes on the outside, inside, and stuff like that. So if you had like 14 going into, I don't know, 8, right? Remember, I always like to show like somebody pushing this over. So it's going to push, and then the 14 would fall inside, and then the 8 would fall here. So don't forget about that. And here we go. How many times does 8 go into 1? It doesn't, but it does go into 14 at least once. Do our multiplying and then subtracting. That's the algorithm. 6, eek, partially repeating. So this is going to go up there, so make sure nice and organized. And I get to bring down a 0. Does 8 go into 60? I think it goes about 7 times. And this is gonna be a nice question. I love it when I make up questions and it ends up being really nice. And there you go, 1.75. 1.75. Pretty cool. So just make sure the right thing goes on the inside and the correct thing goes on the outside. Don't forget about that. What is my other top tip? The other top tip that always comes up, I'm gonna give you a little word problem top tip. A little word problem. The word of, what does that mean in math? It means to multiply. So for instance, if 2/3 of 200 cats like to sing, how many cats? So of means multiply, so 2/3 of them. So I would multiply that by kind of 200 to figure out what it would be. So 2/3 of 200. That's really ugly. Can I make it not 2/3? Can I do that? Can I make it 2/5? I'm cheating. 2/5. It's not that bad. 2/5. Do you know why I wanted to do that? Because it's going to make things a little bit nicer. I'm going to cross reduce. Make this 40. That's much easier. That's 1. And I multiply across the top, and I'm going to get 40. So 40 cats would be singing. So remember, the of does mean to multiply. Don't be forgetting about that. The other, what are the kind of word problem kind of stuff going to be showing you a little bit? Ratios. Ratios sometimes pop up. Don't forget about ratios. Are just basically, I look at it as parts. So for instance, let's just say we were comparing, I don't know, Jedi to Sith. And I said the ratio was, I don't know, what is the ratio? Usually about 9-to-1. 9-to-1, something like that. So this is just kind of parts. These are parts. How many total parts are there? There are 10 total parts. If I was going to draw it, it would look something like this. And I love the unitary method. That's my favorite, one of my favorite methods. As long as the boxes are the same size. So here is obviously my Sith. I should give them a red color because, you know, Sith are evil. And they go red. And then you got all the other ones, right? So you had 9 bars up here. 1, 2, 3, 4, 5, 6, 7, 8, 9. That's what it kind of looks like. So if the ratio of Jedi to Sith was 9-to-1, and let's say I said there was, I don't know, 100. This is so easy to math though. 100 people in the room. How many do you think would be Jedi and how many would be Sith? So you know there's 10 total parts, and then you're just basically going to be going and dividing by the total. So you'd say 100 divided by those 10 parts. So every box would be 10. So in every single box there would be 10. So you'd be saying that. This is really cool. Unitary always shows you how many more. Teachers might ask you how many more. There's 90 more Jedi than Sith. That would be an interesting sort of question to be doing. So do realize that you can be always, for ratios, I like using unitary and drawing. It is very, very helpful as you kind of move forward. Okay, I hope these tips have really, really helped you. Good luck with all your studying for rationals. And yeah, make sure you subscribe. Send me a message if you have any questions. And have a great day. Thanks all you math Padawans out there. I hope these top tips help you a lot and you rock your next math test. Until next time, go and subscribe and do good things.